Welcome to my YouTube channel. Do well to subscribe if you have not. Today we'll be talking about the empirical formula of a compound. What is the empirical formula? The empirical formula shows the simplest whole number ratio of atoms in a compound. It represents the composition of the compound in its most basic form. For example, glucose has a molecular formula of C6H12O6, but its empirical formula is CH2O. When is the empirical formula used? It is used in identifying unknown compounds. It is also used in determining molecular formula, characterizing ionic compound, and simplifying data. Okay, now we're going to look at the steps involved in calculating the empirical formula of a compound. For the purpose of this lesson, we are going to be stating three steps. Step 1. Convert mass to mole. Use the molar mass of each element to convert the mass to mole. So in step 1, we use the molar mass of each element to convert the mass to mole. We know that mole is equals to mass over molar mass. Step 2. Divide each mole value by the smallest number of mole. So for the second step, we divide each mole value by the smallest number of mole. Step 3. Use the whole number ratio to write the empirical formula. So for our third step, we use the whole number ratio to write the empirical formula. Now, let's take this example. What is the empirical formula of a compound composed of 40 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of oxygen? Before we solve this problem, here is something you should note. If the question provides the composition in percentage instead of gram, we assume that the total mass is 100 grams. For example, if this question came in this way, what is the empirical formula of a compound composed of 40% of carbon, 6.7% of hydrogen, and 53.3% of oxygen? Then you should know that the 40% of carbon is the same as 40 grams of carbon since the total mass is 100 grams. So now let's solve that problem using the steps we highlighted previously. So the first step, we said we're going to convert the mass to mole using the molar mass of each element. So that is, in the first step, we're going to divide the mass of each element by its molar mass. So we have three elements here: carbon, hydrogen, and oxygen. Carbon has a mass of 40, hydrogen has a mass of 6.7, and oxygen has a mass of 53.3 grams. So I'm going to divide the mass of carbon by its molar mass, which is 12. So 40 divided by 12, we get 3.3. We also divide hydrogen, the mass of hydrogen, by its molar mass, which is 1. So when we divide 6.7 by 1, we get 6.7. Also, we also divide the mass of oxygen by its molar mass, which is 16. So when we divide 53.3 by 16, we get 3.3 moles of oxygen. So the second step involves dividing each mole value by the smallest number of mole. Here the smallest number of mole is 3.33. So we're going to use 3.33 to divide each mole value. 3.33 divided by 3.33, we have 1. 6.7 divided by 3.33, we have 2. 3.33 divided by 3.33, we also have 1. So for the third step, we said use the whole number ratio to write the empirical formula. So according to our results, we have carbon, hydrogen, and oxygen in a ratio of 1 to 2 to 1. Therefore, the empirical formula of that compound is CH2O.